Hi everyone, this is lecture 2. So we are still in section 1.3, algebraic expressions, but now we're going to talk about part 2. So in the last section, we talked about simplifying our expressions, and now we're going to talk about factoring. So factoring is going to be super common as we go through both this course and in calculus, so we want to make sure that we're good to go with factoring. Okay. So factoring just means that you're representing a polynomial with a product, meaning multiplication, of two or more polynomials. Okay, so we're going to factor things out. So how do we do that? Well, the first way that we do that is by using a common factor. So that means you're going to look at all your terms and you're going to say, what do they have in common? What is their greatest common factor? And you're going to pull that out front. So when I look at 4x squared minus 6x plus 2, I'm looking at those three terms and I'm saying, what do they all have in common? Well, they're all even, so they all have a factor of 2 in there. They don't all have x's, so they don't have any common x's. So the only thing that they have in common is a 2. So I'm going to move that out front, right? And then what's left, I essentially divide through my polynomial by 2. So if I take 4 divided by 2, that's going to leave me with a 2 and an x squared. If I divide the negative 6x by 2, that's going to leave me with a minus 3x. And if I divide that plus 2 by 2, I'm left with plus 1, right? And you should be able to check it because if you distribute your 2, you should get exactly what you started with. So a quick check. When we distribute it, you do get 4x squared minus 6x plus 2, and it's exactly what you started with. All right, now if we look at something with more terms, more going on in our terms, here we have numbers, x's, and y's. And so we're going to look at each piece of that separately and take what they have in common. So for the number part, I'm looking at the 12, the 18, and the 24. 12, 18, and 24, let's see. Well, 12 and 24 have a common 12 or a common 6, and 18 doesn't have a 12, but it does have a 6, right? 18 is 6 times 3. So that means they have a common 6. So I'm going to take the 6 out front. So this is equal to 6. Now, then we're going to look at the x part. This one has 2 x's, 3 x's, 2 x's. So each of the terms has at least 2 x's. So an x squared is going to be my common factor. So we're going to take an x squared. Then I'm going to look at the y's. So y squared, y cubed. They also all have at least 2 y's. So that means I'm going to take out a y squared. Now, what's left? So if I look at this first term, the 12x squared, y squared, and I take out the 6 from the 12, there's a 2 left, right? Because 6 times 2 is 12. I have 2 x's and I pulled out 2 x's, so there's no x's left. There were 2 y's and I took out 2 y's, and so there are no y's left. So it's just 2. Okay. If we go to the next term, that's this one. Okay, now I've got negative 18 and I took a 6 out of there. So negative 18 divided by 6 would be negative 3. I had x cubed, so 3 x's, but I took out 2 to the front, so that leaves me with 1 left. I had y squared, so 2 y's, and I took 2 y's out to the front, so I don't have any y's left. So just negative 3x. And then this last one out here. When I look at the 24, 24 divided by 6 is going to give me a positive 4. I have x squared, and I factored out an x squared, so I don't have any x's left. I have y cubed, and I factored out 2 y's. That leaves me with 1 y. Okay. And then you can go ahead and check that when you multiply that through, you end up exactly where we started. Okay, so that is factoring. Sorry. By greatest common factor. Okay, now, the next factoring that we want to do is to look at factoring trinomials. So usually quadratic things, so I mean things with an x squared, an x, and a non-x term. And first we're going to separate the ones where the leading coefficient is just 1, right? The number in front of the highest power. And so what we're going to do here is we are going to look at factors of the third coefficient that add to the middle one. So I want, if I look at this first one, I need 2 numbers that that multiply to the negative 35, but add to negative 2. So factors of negative 35. Well, 35 is 1 and 35, right? Now it's negative, so one of them would have to be negative. So I could do negative 1 and 35 or 1 and negative 35. I also, 35 is 5 times 7, so I could do negative 5 and positive 7 or negative 7 and positive 5. And I think really that's it, right? The question is, do any of these add up to negative 2, right? I'm trying to add to the middle number. So if I add these, this is going to give me 34. This will give me negative 34. This will give me positive 2. And this one is the magic one that gives me negative 2. So that's what I want. I want negative 7 and 5. So when that happens, my answer then is x minus 7 and x plus 5. Right? So I take these two numbers and they become the part of my binomial. Right? And if we check this, if you multiply it out, so take that first x times everything in the second parentheses, that's going to give you x squared plus 5x. Then take the negative 7 and distribute that to both pieces. That'll give you negative 7x and negative 35, and it ends up right back where I want to be at x squared minus 2x minus 35. So that means that this is the correct factorization. Okay. Now, you don't have to write all that out if you can see what's going on, but you can write out as much as you need to. All right. Letter B, if we have x squared minus 5x plus 6. Now I'm looking at this last number, so I'm looking at positive 6. So I need two numbers that are going to multiply to positive 6. My options are 1 and 6 and 2 and 3, right? Well, depending on what's positive and negative, combinations of these will both get me 5, so we have to look at signs. So positive 6 means that they both have to have the same sign. So 1 and 6 will work, and negative 1, negative 6 will work. Negative 2, negative 3, and positive 2 and 3 also multiply to 6. Question is, which of these four combinations are going to add to negative 5? Well, the positive ones will give me positive answers, so that's not going to work. So it's got to be one of the two negative ones. It's going to be this one, right? Negative 2 and negative 3 multiply to 6, but add to negative 5. And so that means that my factorization is x minus 2 and x minus 3. Now, if you like plus negative instead of minus, that's fine too. But this is what we want as our final answer. Okay. So that's how we factor when our coefficient is just a 1. Okay. Now, what do we do when that leading coefficient is not a 1? Okay. Now, the way that I was taught this was just to kind of guess and check and make it work. But I got a strategy for you here. We're going to call this the box and circle method. Okay, so the first thing I'm going to do is I'm going to make a box. And I'm going to cut it into 4 spaces. Okay. The leading term, this one right here, goes in the upper left box. So 2x squared goes right here. The last term, the constant, the negative 12, make sure you take the sign with you, goes in the bottom bottom right. So negative 12 goes here. Okay. Now, what I do, this is called a box and circle method. So in the circle that I'm going to draw goes the product of those two things. So 2x squared and negative 12. And really, I'm just worried about the number here. So 2 and negative 12, when I multiply them, I get negative 24. Now what I'm going to do is I'm going to use the negative 24 the same way that I used that last term up above when we didn't have a coefficient. So I'm going to say I need two factors of 24 that are going to add to the middle guy over here, the plus 5. So I need two numbers that multiply to negative 24 but add to 5. So factors of 24, let's see, I've got 1 and 24. That's not going to get me close to 5, whether you add or subtract. 2 and 12. If I add them, it's 14. If I subtract, it's 10. That doesn't get me a 5. 3 and 8. Okay, if I add them, that's 12. If I subtract them, that's 5. Okay, so that one has potential. So if I need negative 24, that means I need one of them to be negative. So that means either it's negative 3 and 8, or it's negative 8 and positive 3. Which one will give me positive 5? Well, negative 8 plus 3 would give me negative 5, so it's this one, negative 3 and 8. Okay. Now that I know that, what do I do? Well, what I'm going to do is I'm going to put those in one of the two empty boxes with an X, okay? Doesn't matter which box. So I'm going to put the -3 up here and the 8 down here. You could interchange those if you like, okay? Then what I'm going to do is I'm going to factor this box. So I'm going to look at the top row. So right now in the top row is the 2x squared and the -3x. What do those two things have in common? Well, they both have an x, and 2 and -3 don't have any common factors. So I'm going to pull the x out to the left-hand side of the box. So I'm going to put it here. Okay. When I take that out of the 2x squared, I'm left with 2x. I'm going to put that up top. That way it's kind of like Battleship, right? 2x times x gives me what's in the box. And with the -3x, if I pull the x out to the side, then the -3 goes up top. In the bottom row, the 8x, I have a 2x up top. So if I take the 2x up top, then I'm left with 4, right? If I divide it by 8x by 2x, I'm left with 4. So that goes to the side. And then you just want to check and make sure that your last box works. So -3 times 4 gives me the -12 that's in the position. And that means that my two factors, whoops, sorry about that, are this one and this one. So that means that this is equal to x plus 4 times 2x minus 3. Right? So it's just those two expressions if we essentially put a plus sign in between. Okay? And that is how we factor a trinomial with a coefficient in front. Okay, so box and circle. Let's do another one. Okay, now, so we've got a coefficient sitting right here. That means I'm going box and circle. So here's my box. Cut it into 4s. The leading term, the 6x squared, goes top left. The constant term, the +3, goes bottom right. In my circle is those two things multiplied together. So 6 times 3 gives me +18. Now I'm looking for factors of 18. They're going to add to -11. Okay, so with 18, let's see, I've got 1 and 18. That's not going to give me 11. 2 and 9. Ooh, if I add those together, that's 11. That's 11. But do I need them to be positive or negative? I need them to add to -11. So 2 and 9 won't do it. But if I make them both negative, then -2 times -9 is +18. And when you add them together, you get -11. So I'm going to use that one. So I'm going to put those in the two empty spaces. So -2x and -9x. Again, doesn't matter which way you go with those. It's totally fine. All right, now we're looking at the top row. So I'm looking for the 6x squared and the -9x. What do they have in common? Well, they both have an x. I'm going to move that to the side. And 6 and -9 both have a common 3. So I'm going to pull that out to the side. When you take the 3x out of 6x squared, there is 2x left, so that goes up top. When you take 3x out of the -9x, meaning you're dividing it, that gives you a -3. Okay. So then down here on the bottom, when I have my -2x, I already have a +2x up top. So what do I have to multiply that by to get -2x? Well, a -1. And then we check, does -3 times -1 give me the +3 that's in my box? It sure does. And so that means my two factors are the ones across the top and down the side. So 2x minus 3, which is across the top up there, and 3x minus 1, which is along the side. And that is my final answer. Okay, so this is if you know how to guess and check and that works for you, or you have a different strategy, that's totally fine. But this is a nice little picture way of figuring this out. Way to organize your thoughts that you can always use to factor a trinomial that has a leading coefficient. All right, let's see, factor by grouping. All right, so factor by grouping is a giveaway when we've got 4 terms. And what I want to do, I want to group these so that they have something in common, okay? So I want to put 2 things together that have something in common and 2 other things that have something in common. So the way it's written, I could go with this one and this one, and then that would leave these 2 that have something in common. Or I'm actually, I think, going to go with them just in the order that they are. So I'm going to look at these 2 first, separately from these 2. And I'm going to look at just those two and say, what do those two have in common? Well, they don't have any numbers in common, but they do have x's. They both have two x's, so I'm going to pull that x squared out front. And when you take out the x squared, I'm left with 2x minus 3. Okay. Then I've got the plus sign here. And 2x and negative 3 don't have anything in common, so that's just 1 times 2x minus 3. Right? Okay, now we have two terms. Here's one term, here's another term, okay, because terms are added together, right? Now, what do those two terms have in common? Well, they both have a 2x minus 3 in them. So I'm going to move that all the way out front. So I'm going to take 2x minus 3 all the way out front. And what's left, if you take the 2x minus 3 away, is in the first piece, I'm just left with an x squared. Plus, in the second term, if you take the 2x minus 3 away, I'm left with a 1. And so that means my answer is just these two things multiplied together. 2x minus 3 times x squared plus 1. Okay, so it's kind of like double factoring. I split it into two little groups and I factor what they have in common. And then I look at the two big terms and factor out whatever's in common. If you group them and you factor and you don't get something in common, then that means you didn't group properly. Try to mix up your groupings and try again. Okay. Let's see it one more time. Again, I'm going to stick with the order that they're in and go with these two together and these two together. So for my first two, again, the 2 and the 3, they don't have any common factors, but both terms have an x squared. So I'm going to bring the x squared out front. And when I take out the x squared, I'll have 3x left. And when I take out the x squared from the second term, it's just a 2 that's left over. When I look at the second two terms, and make sure you take the sign with each piece, they both have a negative. So I'm going to take the negative. I'm looking at 12 and 8, and 12 and 8 both have a common 4. But they don't have common x's because the 8 doesn't have any x's. So just a negative 4. And when I factor that out, I'm left with a 3x, right? Because 12 divided by 4 is 3. And negative 8 divided by negative 4 is 2. So positive 2. Now look at what we've got. We've got inside parentheses that 3x plus 2 is the same in both places. So we're going to bring that to the front. And what's left in the first term is an x squared. In the second term is a minus 4. Okay. Now, we didn't get there yet, but this is now a special factor, right? This is a special one. This is a difference of two squares, and it can be factored again. We'll come back in 1 second and finish that one up. So that's what's on our special factoring formulas. A difference of two squares is when you have two squares and they're being subtracted. This does not work if they're being added. The way that you factor it is you take off the squares and you do one with a minus and one with a plus. So it's a minus b and a plus b. So here, 4x squared, if you take the square root of that, that's 2x. If you take the square root of 9, that's 3. And so that means the way this gets factored, because it's subtraction, becomes 2x plus 3 and 2x minus 3. Okay. So up here, where we had x squared minus 4, both of these two are perfect squares. The square root of x squared is x, the square root of 4 is 2, and so that means I would bring my 3x plus 2 with me, but now I'm going to factor the second one as x plus 2 and x minus 2. And that is my final answer. Okay. And then for cubes, right? X cubed is a perfect cube and 27 is a perfect cube. We can do this whether they are being added or being subtracted. And the formula looks like this. Okay. So if you have a perfect cube plus or minus a perfect cube, now with the plus minus signs here, you're just going to read the row. So if it's this one, if it's a cubed plus b cubed, then it's a plus b and a squared minus ab plus b squared. And if it's minus, then it's a minus b and a squared plus ab plus b squared. If you notice, this last sign is always a plus, but these two are always opposite, and the first one matches what you started with. Okay, so that's how you can kind of remember. So an example of that would be this one, x cubed minus 27. The cube root of x cubed is just x. The cube root of 27 is 3. So that means that this will become x minus 3 because I keep the same sign that I had. Then I square I take my first term squared, so x squared. I use the opposite sign, so I used minus, so now I use plus. Then I multiply them together, 3x. And the last one is always positive, and I square the 3. And that is my final answer. That's going to take us to our guided practice.